just to refresh your memory in case you're like, I can't remember any of this, this is where we started. Then we sort of had a lot of intervening working in between here. We introduced our t results, we converted it out, got it to a quadratic equation, and then this is what we got after using the formula, okay? After this point, we took tan inverse, and this is where things started to get confusing. Okay, so let me see if I can explain it a little bit clearer. Now you remember that the first thing we noticed is out of the two solutions, within this new modified domain, right, 0 to 3.14, okay, this solution's fine, okay, but this solution turns out to be a dud because it's outside the domain, right, because negative. So the question that we were getting sort of twisted and turned on was, well, okay, how do we get it into the right domain? All right. So I've got two ways for you to think about it. I'll give you both, but I'm going to tell you which one I prefer at the end. For how do I get it in the right domain, and how do I know that that's the right way to get in the right domain? So here's option one. Okay. Right over here. Ooh, this is really deep. The first option is, you can remember that this is a tan curve. Okay, so irrespective of what is in here, okay, I mean, if this was tan theta equals this, so you take tan inverse, so you had some angle equal to this, okay? Now the period of regular old unchanged tan is pi, okay? Every pi you get a new log. So therefore, the first thing you can do is go from this line, this one, to this one, okay? So what you're doing is you're shifting the answer. Now this is what we did last time, okay? Now, if you do that, you get a number out. Let's see here. I think it's 2.6 something. 2.62, 3, 6, 3. And then to get the actual answer that we want, you multiply by 2 at that point, which is how you get 5.26, and so on. Okay. Now, this is what I'm going to recommend. Okay, because I think adding pi, you always add pi regardless of what's going to be in here. But the question that Richard posed yesterday was, well, hold on a sec, why pi? Because if you're thinking about tan x on 2, what it looks like is very similar to the regular tan curve, but what does this on 2 do? What does that half, that coefficient, right? It stretches it out, okay? So if you remember, I mean, if I did it the other way around, this tells you that you get 2 lots of the whole curve in the normal space. It doubles the frequency, which is halving the period, okay? But if I've got a half at the front, it's stretched it out. So instead of this being 2 pi over here, it's no, sorry, it's 4 pi. No, wait, hold on. Yeah, it's stretched out. I'm getting myself confused again. Okay, now, so therefore the question was, why don't I add 2 pi? Because the period of this thing is 2 pi. Okay, because there's my complete cycle. Okay, now here's the thing which, this is what I had trouble explaining yesterday, and I saw the breakthrough. You really are actually adding 2 pi. You are adding 2 pi. It's just not that obvious, okay? So, let me make it more obvious if you think about it from that line, right? X on 2 is equal to this, okay? Now, you're really adding 2 pi because from here to here, right? Sorry, actually from here to here, you've multiplied, right? So adding pi here is really adding 2 pi, the full period, right? By the end, right? It's 6.28, what have you, okay? So therefore, you have this other option. Instead of shifting it first, okay, you can go to here and you can multiply through first, okay? So I guess that would give you minus 1.022, something like that, maybe 23, I'm not sure how the decimal goes, okay? So having multiplied through by 2, now you can apply your shift, which as we've noticed, really should be 2 pi. Okay, so x equals this. Okay, which is the real period of tan x on 2. Okay, so it's going to give you the same result, obviously. Okay, so which do you do first? Do you add first and then multiply, or do you multiply first and then add? I think it makes more sense to add first, okay? Because it's always going to be pi, regardless of how you've mucked around with this period. Okay, it could be x on 3, x on 4, x on a potato, whatever. Whereas here, okay, you have to think about, okay, what should I add and how will it be different? Okay, which I think is more confusing. So I prefer to add and then multiply. But that's the reason why I'm not adding 2 pi here, because I really am adding 2 pi. It just only appears to be 2 pi later on.
Are you like sort of adding 2 pi on 2?
Yes, because it's x on 2. The whole thing is on 2, as it were. Okay, that's what we get after using these t results. Okay. So hopefully that clears it up a little bit. There's my first way. There's my second way. Either way is fine. I do think it's important that even if you don't write it like this, okay, you don't just go from this line to the next line with no break, okay? Because minus 1.022 is not the same as minus 1.022 plus 2 pi. In this case, they are equivalent because of this shift, but these two lines aren't equal, if that makes sense. Okay? So again, this is the way I recommend. Any questions?
So would you have to write shift in between?
Okay, I would probably say but. Maybe in here, because this is the method I prefer, I would say but, and then you cite the domain, right? You cite the domain. So because it's outside of 0 to pi, that answer, therefore you take this, which is an equivalent answer because trig functions are periodic, okay? So just the key is just to not have this flows onto that directly because it doesn't, okay? It's kind of a similar error to when you've got some function, okay, and then you differentiate it. And then you're thinking, the question was like find stationary points or something like that. So your next line does this. Okay, but that's not true. It's only true at certain points, right? So there's a break between these two lines, which you're sort of not actually talking about. It's sort of implied in your head and you haven't said why. Okay, so it's the same kind of deal here. All right?
Wait, can you pause up?